So I talked about this vol exponent. So again, the Heston comes from a square root process, and the Stein and Stein model is a Gaussian model. So you got the mean reversion and Gauss. So you have a parameter of exponent of 0 if you want, and then you have the Hagen model, which is geometric bounding motion, yeah, for the vol. Yeah. So that's basically parameter 1, and arguably that Hagen model is more in line with what the market does. I mean, you can ask yourself who's first. Yeah, if Hagen, these guys work at Barclays and Bank of America, for example, then or JP Morgan or whatever. Yeah, I mean, these guys are going to have some impact on the market if they all decide they're going to price their vanilla products with this Hagen kind of model. Then that's what the life is. Yeah, I mean, it's, you know, the same in rates. Yeah, I mean, rates. Everybody's sitting on a Sabre formula. Doesn't mean has anything to do with reality. I mean, we talk about social engineering here. It's not, you know, it's not real. Yeah, it's not like physics. Yeah, but okay. I mean, whatever. I mean, you cannot go against the flow. I mean, if everybody uses some formula, you're better off using the same as well, unless you really think you're smart enough to punt against the market. I mean, but then you might be out of your pocket pretty quickly. Yeah. Okay, so that's maybe not our business here. I mean, if you say most banks, you just want to do what everybody else does. Yeah. So what everybody else does is using the Hagen formula. Yeah. That's what I'm saying in short. Scott-Cheney is a bit similar. You have a also log normal mean reverting. So you basically do a mean reversion on the exponential if you want, or you do. Okay, the Hagen model actually is pretty poor because there's no mean reversion there. Yeah, I mean, Hagen cannot provide a formula for implied vols, assuming a mean reversion. I mean, that breaks down. Yeah. So if, in that sense, the model is somewhat non-stationary. As I said, I mean, the volatility is going to be ever wider, and there's no long-term stationary distribution for the variance, yeah, because there's no mean reversion. That's why you basically need a. I mean, the Hagen formula, which gives you basically the approximation for that model for the vanilla implied vols, it needs a strong time dependence. If you describe your implied vol surface in terms of this Hagen formula, you're going to find that you need a decrease of the vol of vol. Your alpha has to be lower than the long end. And what I said is, for consistency, you want that alpha squared t is not decreasing. Yeah? So total variance shouldn't decrease. Yeah? But I mean, again, it's a bit kind of rule of thumb kind of stuff. Yeah? But you want your total variance of the vol process not to decrease. But what you find from simply calibrating your time slice by time slice, you're going to find that the variance is going to go, the alpha is going to be decreasing in time, and that basically points to this mean reversion thing. Yeah? If you had a mean reversion in this Hagen formula here, if there was a mean reversion on top, you could get away with a constant alpha. Yeah? But I guess you wouldn't do that because that would be close to this model actually. But then you don't have a closed form for that. Yeah? For example, the Stein and Stein, I mean, that's a model which is actually a bit overlooked. It's okay, it has negative vols, which you might not like. Yeah? You kind of, but in a way, when it gets negative, you just flip it over. So it kind of reduces the correlation because now it just goes the other way around. But the model has as easy analytics as Heston. So it's actually quite useful to look at this as a variant. Okay, the Hagen formula has these nice features, implied vol function, and the Scott-Cheney is maybe the best model. Some people, you know, if you believe Gatherell about this exponent of vol being proportional to sigma, then Scott-Cheney is good, but there's no closed form. Yeah? So then you're kind of fighting with numerical schemes to get this calibrated. Okay, so that's maybe some of these three models. I mean, there's a whole zoo of models, but I would say most people are probably happy if they get their Heston nicely integrated into their systems.